Okay, if you are in Math 7, we are working from the Advanced 2 textbook. If you are in Math 8, we are working from the Course 3 textbook. We are doing Chapter 6 test review, 6.4 to 6.5, and it can be found on pages 280 and 281. Okay, the first part of our review is determining whether something is a linear function or a nonlinear function. So the book will give us a table that looks like this. X, Y, 3, 4, 5, 6. 2, 4, 6, 8. And they're telling us that this table is a function, but we want to know, is it a linear function or a nonlinear function? So we need to know, does this table show a constant rate of change or not? So we need to look at the patterns. So here, my x's show a consistent increase of +1. Now let's take a look at our y's. Our y's show a consistent increase of +2. So as x increases by 1, y increases by 2. Since this is a constant increase, +2, +2, +2, we do have a constant rate of change. Therefore, this represents a linear function. Okay, next, they show us another table, X, Y. And we have 2, 5, 8, and 11, 4, 7, 12, 19. And they want to know, does this table represent a linear or a nonlinear function? Well, let's take a look. +3, +3, +3, +3, +5, +7. Uh-oh. This is not a constant rate of change. We have a +3, a +5, and a +7. It is not the same. Therefore, it is not constant. So we can say, as x increases by 3, y increases by a different amount. It's not constant. We have a +3, a +5, and a +7. It's not the same. It's not constant. Therefore, this is not a constant rate of change. So this represents a non-linear function. So this is a linear function. This table represents a linear function. This table represents a non-linear function. Okay, let's take a look at graphs. So in this graph, the graph is not a line. And remember, the definition of a line is the shortest distance between 2 points. So it needs to be a straight line. This is not a straight line. It's not straight. Therefore, this is a non-linear graph. Now, the book may also show you a graph that looks like this. Whoomp, whoomp. And they want to know, does this represent a linear function? Well, the graph is non-linear. The graph is non-linear. It is made up of two linear sections. It is made up of two linear sections, but the graph itself is non-linear because it is not a straight line. So they may throw something at you that looks like that and ask, well, is this graph linear? The whole graph is non-linear. It's made up of two linear sections, but the whole graph is non-linear. Okay? So then we have some graphs that can look like this. So in this case, both graphs are lines. It is the shortest distance between 2 points is a straight line. The shortest distance between 2 points is a straight line. So both graphs are lines. They are both straight. Therefore, they both represent linear functions. So these are what linear graphs look like, and this is what non-linear graphs look like. Okay. Then the book will give us equations. And they want to know, does this equation represent a linear function or not? And we know that linear equations can be written as y equals mx plus b. So they give us this equation, y equals 3x, and ask, is this a linear function? Does this represent a straight line? Well, it does, because remember the plus b is an invisible plus 0. And it's invisible. The plus b is there. It's just plus 0. And we don't typically write plus 0. So it's invisible. So yes, this represents a linear function. Then the book will give us another equation that looks like this. Y equals 2 times x plus 3. And they want to know, does this represent a linear function? Well, how about if we rework it? Y equals 2x plus 6. Oh, would you look at that? Y equals mx plus b. It does follow the slope-intercept form. So, yes, this equation represents a linear function. Then they try to get all tricky on us and give us this equation. Y equals 5.2. Now, we need to remember that this is a flat line. It's a flat line, so it has a slope of 0. It's a flat line and it has a slope of 0. So can this be written in y equals mx plus b format? Well, y equals, it has a slope of 0, x plus 5.2. Can it be written in y equals mx plus b format? Yes, it can. With a slope of 0, anything times 0 is 0. So we don't typically write that. It's invisible. It's there. It's just invisible. So yes, this represents a linear function. Okay, now we know linear functions can be written as y equals mx plus b. And the book gives us this equation, y equals 4x. Does this represent a linear function? Well, can we rewrite it into y equals mx plus b format? Let's see. Y equals 4x. I need to get x to the top. So I'm going to multiply this side by x and this side by x. I have xy equals 4. These cancel. Okay, now I need to isolate y. I need to get y by itself. So to do that, I'm going to divide this side by x, divide this side by x. Wait, what? Y equals 4x. Guess what? This cannot be written in slope-intercept form. It cannot be written in slope-intercept form. Therefore, it represents a non-linear function. A non-linear function. So if it can be written in y equals mx plus b format, slope-intercept format, then it's a linear function. If it cannot be written in y equals mx plus b format, then it represents a non-linear function. Okay, and the last part for today is 6.5. 6.5, let's review 6.5. So we have a graph that looks like this. This is curved, therefore it is non-linear, and we do not have a constant rate of change. Okay. When it is going up, when it is positive, this is increasing. It reaches a peak. And then when it's going down, this is decreasing. So nonlinear does not have a constant rate of change. It's usually curved. So here we have whoop, boop, whoop. Okay, just like before, the whole graph is nonlinear. The whole graph is nonlinear, but it is made up of 3 linear sections. And each section has a constant rate of change. Okay? So here, this is increasing at a constant rate. Increasing at a constant rate. This shows no change. And here we are decreasing at a constant rate. So if it's curved, it's nonlinear and it does not have a constant rate. If it's straight, it has a constant rate, and that section is linear. So you may see in your book that the speed increases at a constant rate. So the speed of a car increases at a constant rate, then drives the same speed for a while, then decreases at a constant rate. And here, this is like an airplane. So an airplane is increasing its altitude, reaches a peak, then decreases its altitude, but not at a constant rate. So it's increasing, reaching its peak, then decreasing. Here, this is increasing at a constant rate, holding, and then decreasing at a constant rate. So that's what we're doing today.